Imagine the whole universe as one impossible weight, one motherlode of mass, holding everything still.
Did galaxies tame the Big Bang?
Then it fractures. Not a firework, but a breakup. Galactic-sized chunks of hot molding matter scattering into a forming medium I'll call the kinetic grid. In this kinetic anchor view, those chunks don't just fly forever. They sink, they settle, they polarize the grid like islands pressing into a deep ocean. Over billions and billions of years, they rise to the surface of this gravitational plane, each one becoming an anchor that drags the flow, slows the rush, and carves out calm zones where stable physics can happen. That's why the cosmos looks structured, not smeared. Where anchors cluster, galaxies, the grid is saturated, the storm goes quiet, and stars can orbit, disks can hold, and spiral arms can keep their grace for eons. In the wide dark between these islands, with no weight to press and polarize, the grid's raw push resumes, accelerating like a river freed from a dam. Think of gravity here, not as a distant tug, but as pressure. Mass sitting on the grid, shaping flow. A trillion sun anchor like the Milky Way doesn't just attract, it tames. It caps velocity inside its reach, locking matter into rules that feel slow and sensible to us. That lock explains why galaxies stay whole even while the voids between them race apart. So what about the Hubble expansion we measure? In this frame, that's the leak, the grid's acceleration slipping around the edges of our anchor. We're not watching space get bigger everywhere. We're watching the untamed flow reassert itself once it's far enough from our trillion solar mass drag. Dark energy? Picture a cargo ship punching through water. The bow pushes aside, the sides surge, the wake roars. The vacuum's 2C flow, its raw, untamed rush, gets displaced by these galactic islands, racing through the gaps and giving us the accelerating expansion we map in the deepest surveys. Scale it back to the start. One singular sink pinning the grid at a standstill. The bang shatters it. The grip loosens. Chunks drift, settle, and anchor. The more they press, the calmer the local rules become. The less they press, the faster the grid breathes. And that sets up the endgame question. If mass dominates wherever it chooses to sit, will the grid be fully domesticated, everywhere kneaded into calm by ever-growing anchors? Or will the 2C flow keep prying at the seams, slipping through the cracks, and finally break the anchors apart, returning the universe to motion we can barely imagine?
I don't claim this is settled truth, it's a lens.
Here's a myth I hear a lot. Somewhere out there is the center of the universe, like a glowing core, surrounded by a bubble racing outward at the Hubble rate. It's a great mental picture, but here's the model. Space itself is expanding everywhere, all at once, with no special center. Every distant galaxy sees every other one receding. So where did all the stuff come from? Galaxies, stars, planets, nebulae, if not as debris from some exploding sphere? Let me try a different picture. Imagine the early universe as incredibly smooth foam, tiny quantum ripples blown up by a burst called inflation. Those ripples became gravity's seed plots. Over billions of years, they grew into the cosmic web, filaments, clusters, vast voids between. Now, about that two-universe idea, one positive, one negative may be colliding. In standard cosmology, the Big Bang wasn't an explosion in space, it was an expansion of space. But there's a twist from cutting-edge theory, a CPT symmetric picture where the Big Bang spawns two mirror universes. Ours moves forward in time and is matter-dominated. The other mirrors it moving the other way in time, dominated by antimatter. Not a messy crash, more like a perfectly balanced birth. That brings me to one of physics' biggest puzzles, matter-antimatter asymmetry. The math says the early universe should have made equal amounts of both. If they'd met one-to-one, they'd annihilate, leaving only light. Yet here I am, talking to you, made of matter. The clue is a tiny bias called CP violation, nature's slight preference that might have let a smidge of matter survive. Think of your negative sphere breaking into pieces as a poetic way to ask, Where did the missing antimatter go? We're still looking. What about dark energy, the burnt mesh you mentioned with nowhere to go? In our best model, dark energy is more like a property of empty space itself, with a weird negative pressure. That negative pressure doesn't pull, it pushes, accelerating expansion. If you want a bubble analogy, dark energy is the relentless breath inflating it faster and faster. Gravity from matter tries to knit things together. Dark energy keeps stretching the fabric. And the Hubble rate? It's not a speed limit, it's a relationship. The farther a galaxy is, the faster it recedes because there's more space between us being stretched. Today's measurements even disagree a bit, a Hubble tension that might hint at new physics. So, is there a dual universe collision behind it all? It's a compelling story engine, and versions of it exist in real research. But the simplest, most tested story is this. Quantum ripples inflation gravity's slow sculpting a universe whose fabric is still accelerating apart. Myth makes it vivid. Models make it testable. The wonder is that sometimes the universe gives us a little of both.